Hi, I'm Michael Pfeiffer. This is another episode of Metal Conversations. In this podcast, I'll discuss design for manufacturability, which is related to component fabrication and joining components by welding, brazing, or soldering. Design for manufacturing is concerned with designing components and assemblies that can be repeatedly produced with consistent good quality, without hassles, and at low cost. So before I start, I just want to tell you about some new things going on at Industrial Metallurgists. Recently started a new workshop series that's focused on teaching design engineers about different degradation mechanisms such as galvanic corrosion, pitting, crevice corrosion, adhesive wear, and fatigue, and so on. Each workshop is focused on a specific topic. So the first workshop will be on galvanic corrosion, where I'll present on the mechanism, how the mechanism occurs, the physics of the mechanism, and things that design engineers can do to prevent galvanic corrosion from occurring. These workshops are meant to provide practical information to design engineers. I wouldn't say it's not dumbed down, but what it is just practical aspects of understanding the science behind the mechanisms and the science behind things that you can do to prevent these degradation mechanisms from occurring. So I hope you can join me for the workshops. Information about the workshops is on the website. You can look on. I'm on the blog where there's a posting about the workshops. So now I'm going to talk about design for manufacturability. So during component design, we wanted to engineer the component form and materials to enable components to meet the performance and reliability requirements at low cost and at the lowest possible cost if possible. And when I refer to component form, I'm talking about the size, shape, dimensions, and features of a component. And then the materials are the alloy and maybe any coatings that are on the alloy. So low cost means that the component and the assembly or subassembly consists of low cost materials and that they're easy to fabricate. And so ease of fabrication depends on component's form and the material it's made of. For example, consider a component made of low carbon steel that will be machined. It's easier to machine a low carbon steel that contains sulfur and phosphorus that are added as alloying elements compared to a similar alloy that contains only trace amounts of sulfur and phosphorus, and in that case, they'd only be present as impurities. The added sulfur and phosphorus allows for faster machining compared to the other alloy that contains a small amount of sulfur and phosphorus. Now, the trade-off is that by adding the sulfur and phosphorus to the steel, it improves the machinability, but it also makes the weldability of the steel bad. So if you're going to have to weld the material, then you may want to think about not using the steel that has the higher sulfur and phosphorus added to it. But in any case, we can select materials that are easy to fabricate into the component we want to fabricate or easy to join together. And also people can make decisions that result in making components that are difficult to fabricate and joints that are difficult to create. And that's not a good thing. Design for manufacturability applies to primary component fabrication processes, secondary processing such as coating and heat treating, and also to joining. Primary component fabrication processes include casting, extruding, stamping, and other cold forming, also forging and machining. And secondary processes include heat treating, machining, and coating by painting, electroplating, anodizing, and other processes. And joining includes welding, brazing, soldering, and using adhesives. Now, fabrication and joining costs can be reduced by using materials that are easy to work with. When a fabricator, such as a stamper or an extruder or forger, receives a request for a quote for a component or an assembly, if they see that it's going to be a hassle to make it, they will build the cost of dealing with the hassles into the price that they quote to you. Hassles can be due to the material that was selected, or to the shape and features of the component, or an issue with the joints between components, or a combination of the material and the shape and features. Now, many design engineers focus on performance and reliability requirements, strength, hardness, corrosion resistance, and fatigue resistance, and other things where, thinking about how materials can degrade. But they often don't think about design for manufacturability. And this can have a huge impact on the cost, on the supply chain, that is the companies that are willing to fabricate components for you and fabricate assemblies, and also meeting delivery schedules. And regarding cost, sometimes it makes sense to use a more expensive material that will enable easier fabrication of components, and as a result, lower cost to fabricate and lower cost to join components. From the perspective of supply chain, the design for manufacturability will influence the suppliers that are willing to make component or the assemblies. And in some cases, you may even get no quoted or high quotes. A company may no quote your design because they realize it's such a hassle to make it. They don't want to deal with the hassles, so they're just going to no quote it. So if you've been in circumstances where you've gotten no quoted, it's probably because the supplier didn't want to deal with making your product. It was going to be too much of a hassle, and the costs that they were going to have to charge you for it just weren't going to pay to deal with the hassles. Also, if it's difficult to fabricate components or to make joints, then it can affect the delivery of components and assemblies to you because of quality problems due to problems that your supplier has in making the components and the assemblies. And so that can delay shipments to you and delay your ability to ship your product. When I'm working with a client on designing a component, helping them to select an alloy, I will ask for permission to talk to their suppliers to get their feedback about the materials that I'm considering using in the component or in the subassembly. And usually the suppliers love talking to me because so few engineers talk to them and ask for their input. And they want to help their customers make a good product, and they want things to go smoothly. And they want a project that's not a hassle. So talk to the suppliers before finalizing designs to get their input. That's what I do. And the discussions are always valuable, and you'll be armed with more information and better understand the choices and the trade-offs regarding your concerns about performance and reliability and the supplier's concerns about being able to fabricate the component and the subassembly easily. Also, there may be concerns about being able to source the material. If you select an alloy that is a hassle to source, or there's only one source for it, then that can also increase the cost as well as availability of the material. The same considerations also apply to internal manufacturing and assembly lines within your company. And they also want to get designs that are easy to produce. And if you don't make it easy on them, then they're going to have a problem with the throughput and poor yields because of the extra attention that might be required to fabricate the components and make the assemblies. So talk to the people in your manufacturing lines about your designs to get their input before you finalize the designs. And the earlier this is done during the design process, the more time you'll have to make decisions and to make changes that are necessary in order to engineer a product that meets all your performance and reliability requirements and at the lowest possible cost with few hassles getting things made. So that's it for design for manufacturing. I'd love to hear about your metals engineering experiences and your experiences with design for manufacturing. Feel free to send an email or leave a comment. My email address is mike@imetllc.com. Also, let me know if there's a topic you'd like me to cover. Thanks again for listening. Bye.